Hello, this video is going to go through the first part of the workshop for multi-omic analysis with ELMER. So this workshop will demonstrate how to perform ELMER analysis. We're going to provide users with an R data that contains both RNA-seq and DNA methylation for all samples. And before this workshop, it might be better to have a knowledge of R, and you can search on Google what's a summarized experiment, multi-assay experiment classes, but those are R data structures that contains both genomic and metadata information about the samples. I'm going to explain a little bit later. And it might be better to know what's the DNA methylation, gene expression, and how the data is showed. By the end of this workshop, we expect you to understand what's the input data from ELMER, what's a multi-assay experiment object, and that you are able to execute ELMER and understand the output. So the data to this workshop, also the slides and the tutorial in HTML is also available in this Google Drive folder. Let me see if I have it open. So you have this PDF with the presentation, you have the workshop HTML here, and the data we're going to use is this TCJ esophageal data that contains the DNA methylation only for the distal regions. So you download this, you need R, it might be better to have RStudio, which is the IDE that I'm going to use during this workshop. And you need to install ELMER. You simply can run this code inside the R, and you should have installed ELMER. And also, there is the workshop is also providing these RPubs. So I'm going to open you, and everything I'm going to do in this video is step by step is explained here. Yeah, that's mainly this. This is what we need to know before the workshop. So how the data is presented. We have one single R object that contains both DNA methylation and gene expression, and also the metadata. So the data is structured. So we have the experiments, so RNA-seq and DNA methylation, which can be accessed with this function, experiments. You have another column with the metadata saying patient 1 and all the information like gender, age, etc. And then we have another column mapping the columns from DNA methylation and gene expression to the samples. So this can be accessed with the sample map. So you should have like assay 1 should be like DNA methylation, patient 1, and the name of the column here, RNA-seq, patient 1, and then the name of the column here. So the first step is to load the libraries and the data. So I have already the code here. So the first step is you call library, ELMER, and multi-assay experiment. So this is RStudio, just explaining briefly. We have 4 windows. The upper left one is where you write our code, and the lower one on the left is the R or terminal, where you can execute your code. You can simply highlight the code here and type command return in Mac or Control Enter in Windows, and the code simply is going to be sent here. The right side we have the folder we are working on. You can change the directories going through the menu, or you can just give the path here, and then you simply need to set as working directory, and anything you save or create is going to be saved on this folder. And the menu on the top part is going to be where the objects are. So I'm going to erase everything I have. So right now I should have no objects, and I'm going to read the data that you downloaded. So you just point to the path, and then you load the multi-assay experiment object. And if you write an ELMER, it's going to give you a summary of that object. So we can see we have 2 experiments, DNA methylation and gene expression. Each one has 171 samples. And the DNA methylation has 148,000 probes, while the gene expression has 56,000 genes. And here has some accessors. So like I said, if you write experiments, we just say experiment, it's going to give you that we have DNA methylation and gene expression. If you write code data my, you access the metadata. So I'm going to just show the 5 first rows and 5 first columns. So we have the sample, the patient, short letter, definition. You can see which columns are available if you do code names, code data, which I say experiment. Then you have all the columns from the metadata. And another way you can also access that is with the $sign. And then you have the information you want. If you want like a summary of the numbers, you can do just like a table. Okay, so it's like I have 85 adenocarcinoma samples, and I have 78 squamous cell carcinoma samples, which are the ones we're going to use. So we also have the column definition. And we can see we have like primary solid tumors, solid tissue normal, and metastatic samples. We're only going to use primary solid tumors in this example, so we're going to subset the data. And I'm going to show that later. Yeah, you can actually do that like this. So you can subset a multi-site experiment by rows, by columns, sorry, if you set the filter after the comma. Normally in R, everything before the comma is subsetting the rows, and after subsetting the columns. So since our samples are the columns in our experiment list, we're going to remove it. So we want to keep only the primary solid tumors. So if you run this code and now you do the same table, my definition, you only have 171 samples. Great. Metadata should be there. And then how do I access methylation and expression? So if you get the first item in the experiment list, you should have the methylation. So just to show in a column methylation. So the object is a summarized experiment object, which is also a data structure in R that contains both metadata and genetic data inside. And here are the accessors. So we have metadata that has no information, assays, which should be, so if you assay methylation, you're going to have the beta values for each sample and each probe, which goes from 0 to 1. 0 means unmethylated, 1 means it's methylated. You have the row names, which are the probes, and you can also access the information from the ranges. So you can do like this. Row ranges methylation gives you the metadata information about the probes. So where's the location of each probe and all the metadata within it. You also have the option to write, instead of row ranges, you have row data. So you don't have like the ranges, you remove like start and end and just keep the metadata associated with the probe. Then you have like conames where you get the patient samples, and that's for methylation. And expression is the same. You're going to access the second item in the experiment list, so you can see that the second was gene expression. And again, we also have the row ranges of that object, and this is going to give you the information about the gene, so start and end, and etc. And again, if you say assay, I want the five first columns, 5 first rows. Yeah, rows and then columns. Then you have the expression of each gene. So you can see like the metadata is on the same position as the data, and also the columns are going to have the same. They're on the same order. Great. So this is our data. In ELMER we use the my with both together, then inside of the package it's going to access what we need. Yeah, again, if you say like expression, you can access the metadata of the samples with $. And if you want the metadata from the ranges, you can, for example, just the row ranges and then call the column you want with the $sign. So that's more or less how you can access it. Okay, so this is the first step, understanding the data. The next steps is going to be like selecting which are the samples you are going to use in ELMER, and then performing ELMER analysis. So I'm going to split in another video. And that's for this first part, is understanding the data and preparing your environment. Also, in RStudio, you can check the packages that are installed. Here, just type the name of the package. So ELMER, we are using here 2.9.1 and ELMER data 2.9.3. And that's it. Thank you for watching.